Which of the following is a special purpose register of microprocessor? Okay. In any microprocessor, the instruction register, the accumulator and temporary register, these are general purpose register. Because accumulator, whatever is happening will happen in accumulator and also saved in accumulator by default. This is accumulator. Okay. Now the answer here is instruction register, because the program counter is what? Program counter is different. Program counter holds the address of the next instruction which has to be executed. For example, if this is these are the whole instruction which are in the assembly language. So if we are working on this, PC will hold the address of the next one. Okay. This is 16-bit. How many flip-flops are there in flag register of 8085 microprocessor? So we have the 8-bit register for depicting or showing the flags. So how many flip-flops are there in flag register? See, one flip-flop will have 1 bit. When we take 8 flip-flop, we start calling it as a register. All of these 8-bit are not used because these are flag register. The B1, B3 and B5 is not used. So if 3 is not used from 8-bit, how many are there? 5 is there. So there are 5 flags of flip-flops in a flag register in 8085 microprocessor that shows the status of the arithmetical logical operation. They are mainly affected by the content of, mainly I'm saying, not always, but mainly by the accumulator. Which of the following register is not used in opcode fetch operations? Not used in opcode fetch operation. Okay. See. So any instruction will have 2 parts. The operation code opcode and the operand. Opcode and operand. So which of the following register is not used in opcode fetch operation? So flag register, this is not used in opcode fetch operation. Because this flag register is used to represent the, for example, some operation LDA is there. So this is used to represent the status of arithmetic and logic operation which is performed after decoding the opcode. Once the opcode is decoded, then it is done. Okay, for fetching operation, flag won't be used. Once all things are done, then some operation is performed, then all the flags will be affected. Otherwise, or they are used. Otherwise, fetching the opcode won't. Though this program counter, the memory address register and memory data register, all these 3, they will be the part of fetch operation, not the flag register. Okay. What is stored in the HL general purpose register? See, general register we have B, C, D, E and HL. So this is basically having the address of memory. H, 8-bit register, L, 8-bit register. But if you combine HL, they work as a 16-bit pair. So H and L are 6-bit general purpose register. They are used to store the address of the memory. And as I said, together if you combine 8-bit, 8-bit, they can store 16-bit address, and the address of memory is the answer. Which of the following is true about stack pointer? Okay. The answer here is the stack pointer contains the address of the top of the stack memory. So whenever you are doing some programming, etc., there will be a RAM stack in the RAM. So that will be allocated to you. So there will be a stack pointer. There will be a stack initialization. So the stack pointer is a 16-bit register that will store the data temporarily. For example, if you are running certain program and there is a subroutine. So when you go to the subroutine, you have to have the next address, instruction address to be placed somewhere so that you can recall it when you come back to the main program. And that is only possible when you have stack-like operation. The stack pointer is initialized before the stack operation and store the data not permanently, only temporarily. And stack pointer is initialized before the stack operation. The stack pointer is 16-bit. So it has to be initialized before stack operation, not after the stack operation. Otherwise, it may not have any use. Suppose registers A and B contains 50H and 40H respectively. After instruction move AB, what will be the contents of register A and B? The move is what? A comma B. So the content of B will be transferred to the content of A from source to destination. But the A will have the content of B, but B won't change. B, until you replace it, if A is having 50, B is having 40, when you transfer, when you move, now A will have 40, B will itself have 40 because it was having 40 until it is not being replaced. So the answer will be 40, 40. So that will be A. So A and B both will contain 40, 40H. For how many times per instruction the content of the program counter is placed on the address bus? Now this is a very tricky question because the answer we cannot give. It depends on the length of the instruction. Whenever we decode an opcode, the microprocessor understands then what is the length of the instruction, 1 byte, 2 byte, 3 byte, what have to be performed, how many fetch, how many t-state, how many operations, how many instruction cycles. So the content of the program counter is placed on the address bus. It may be as many times as the length of the instruction. So we cannot tell it right now. It depends totally on the length of the instruction.